So yesterday we did a talk together. It was a 2-hour tutorial on Java EE 6. And then at the end of the presentation, I just quickly showed this as a shameless plug to get you all into this talk. And then at first when I showed the picture, everybody started to laugh because they thought we were making a joke out of it, right? So, of course, well, I admit there's some controversy in it, of course. I mean, that will make it a little bit more fun. But then there's also a very serious message in it. And I hope you're all here for the serious part, because we prepared a, well, 5-step process in order to get rid of Spring and migrate your existing Spring applications towards Java EE 6. And we're going to tell you all about it in the next hour. So before we begin, let's just briefly introduce ourselves. We already did a number of talks, so actually we assume everybody has seen us now a couple of times already, maybe. So this is Paul. Paul and I both work for Luminous in the Netherlands, which is a consulting company of about 100 people. We do Java, a lot of Java, ranging from enterprise systems to mobile. And then besides our services departments, we also have a R&D division. That's where Paul is working. And Paul is doing a lot of open source. And he's also working on our Amdatu cloud innovation platform. So if you're interested, take a look at that. And if you want to reach out to us, please do so on Twitter. So the first question to ask when attending this talk is, who is this talk actually for? So I take it that you're well, interested in Java EE because it has seen a lot of uptake in the past couple of maybe the last couple years, 2 years or so. There's a lot of uptake for Java EE. I mean, well, honestly, Java EE hasn't been so hot like, say, 5, 6, 7 years ago, right? So that moved a lot of people into the arms of Rod Johnson and the Spring guys. And, well, maybe you've read their books, the J2EE design and development book. And that book addressed some, well, some issues in the Java, or actually in the J2EE platform by that time. And those issues were valid. And he made some really good arguments and some really strong points in order to get them solved. But they weren't really picked up by the Standards Commission. That took a while. It took maybe 6, 7 years or so. But now, over the past couple of years, the standards are really on par with what you need today. So Java EE seems to be hot again, so that might get you interested into being here and looking into how to get your Spring applications converted into Java EE applications. And we have actually a valid business case for that as well, but we'll come to that in a couple of slides. So why do you want to listen to us? Well, maybe just like you, Paul and I had like endless discussions about which frameworks and which tool stacks to use. And those discussions actually started friendly, with a couple of beers or something like that. And then finally we started shouting and scratching each other's cars, right? So you might recognize that, maybe from your own experience. And well, actually we've been building with all of the stacks, right? We've been doing J2EE applications maybe in the early 2000s. We've been doing Spring applications meanwhile, and the last couple of years we've been building a lot of Java EE stuff. So the important thing to note here that we are not working for any application server vendor. I mean, there's currently 14 application servers certified out there for Java EE 6, but we're not working for any one of them, and just to get it straight, we are actually no Rod Johnson groupies either, right? But you might have guessed that from my first slide. So why do you want to migrate? And this is a valid question to ask. I mean, it might be a religious thing, right? You might be a Spring hater or whatever. I mean, well, that's funny for talks and over drinks. But I don't think there are much customers out there who will just give you like a blank check and say, okay, well, convert all my Spring applications to Java EE. Here you go. All right. So that's not a valid business case. So we have to find a business case. So the business case that we think that might be really relevant is that you have been building Spring applications for the past, well, 5, 6, 7 years maybe. And you have built such an application, let's say 5 years ago, and it uses, for example, a number of outdated frameworks. For example, you chose a web framework that was really hot then, but today isn't really hot anymore. In fact, it might be dead already, right? So no longer supported, or there might be no longer updates for that particular framework. Same goes for persistence. Well, maybe you used some JDO in the past or something like that, right? Not really a current framework anymore. So you might have some technical depth in those applications, right? So you're facing some serious issues in those applications because, well, they have been running in production for the past 5 years, and your boss wants them to run in production for the next 10, 15 years, right? So if you're facing technical debt and issues with those applications, then you are, well, that will require some work anyway, right? So you have a number of choices. Well, upgrade to a newer version of the Spring framework and use some newer frameworks on top of that. Or maybe consider taking a little bit of an extra step and going to the standard. And the standard is important because it will guarantee you that your stack, your platform, will be maintained for the next 5, 10, 15, maybe 20 years. I mean, Java has come a long way, 17 years. There's some deprecation in it, maybe not enough, but it has been maintained over all those years, right? So if you want your application to go for another 10, 15 years, it might not be a bad idea to go to a standard that a lot of vendors agreed upon, a standard which is available all around you in 14 available application servers, and a standard which has some really current frameworks on which you can build excellent applications with. So you are facing some serious upgrade issues, and now you're facing the decision whether you just want to stick with your Spring Stack, which, well, may be good in your particular situation, but if you want to have a choice, if you want to go the other way, we will show you in the next hour or 50 minutes, we will show you how to do that, right? And then again, let's not forget Spring is a proprietary technology, right? So it started out as a great open source initiative. Then there came some vendor capitalists along. Then there came some commercial companies along. And now, after a while, it's in the hand of a company called VMware. And, well, I don't know about you, but I don't really know VMware in the Java world, right? What are they best known for in the Java world? What's their biggest contribution? The only thing I can think of is being able to run Windows on my Mac. But I'm not sure that's a really great thing, right? So, okay, I used a lot of words already, but sometimes you have to show little pictures to make it a little bit more interesting. So, the choice that you've made in the past, in the past 5 years or so, they might have been competitive and great by that time. So there might have been good decisions like 5, 6, 7 years ago. But now, after a while, facing some challenges, facing some, well, maybe you should add some new functionality to the application as well, you might need something else, right? So you might need some other features. So just to get it straight, this is not my company car. I would really love it to be so. I mean, the make is the same, but that's where the equation ends, right? So before we dive into the actual migration path, let's get a couple of misunderstandings out of the way first. The first thing is this one. As soon as we start talking Java EE, some people, well, they say, okay, well, Java EE, wasn't that supposed to be, you know, fat and, you know, a lot of boilerplate and heavyweight and slow, right? That's what most people remember it from, right? So there's a number of people out there that think that Java EE stands for Java Evil Edition, right? Yeah, all right. And that might have been the case in the past, but it's no longer the case, right? So now it's just Enterprise Edition. And things have dramatically improved, and it was about time. So if you take a look at application server startup times, for example, they used to be like 30 seconds, right? Or if you had WebSphere or WebLogic, it would take you like 5, 10 minutes just to start up your application server. And some of us are probably still facing those startup times today, right? Those were horrible. So the complete container architecture has been overhauled, completely overhauled. The complete programming model has been overhauled. So it's now all based on lightweight POJO-based programming, and this reflects in the startup times. So for example, if you take a JBoss application server, the latest version, that will just, well, start up in about 2 seconds, right? So it's blazing fast. Same thing goes for Glassfish and some of the other application servers, just a couple of seconds just to boot up the application server. If you compare that to a Tomcat Spring Stack, it's about the same, right? And then this is a basic Tomcat Spring Stack. But as soon as you're building a more interesting, more complex application, you start stacking frameworks on top of the Tomcat Spring combination. So actually you're building your own application server within your application, and then the startup time will just eventually grow, right? The good thing about Java EE6 is also that you can keep your deployment artifacts pretty much, well, really small. I mean, because a lot is already contained within the application server, the only thing you need is just the code that is going to use those services. So typical application is maybe just a couple of 100 kilobytes, right? So a couple of 100 kilobytes jar file or WAR file will just boot up really quick in the application server. So here's one of our favorite quotes. It's from a JBoss guy. And he says, well, nowhere in the Java EE spec does it say that Java EE server should be heavyweight and slow. Well, some vendors might have read that somewhere in the spec, like a couple of years back. But now it's clarified that it's no longer the case to make a heavyweight and slow application server, right? So, okay, you think, well, that's nice. But, you know, when I build my next application, I just need to have dependency injection, right? Okay, fair enough. I mean, dependency injection was really popularized by the Spring framework. well, let me get it straight. It wasn't their invention, right? So dependency injection is something which is like a pattern which comes from the late 80s, I believe. But it has been heavily popularized by the implementation of the Spring framework. And dependency injection is actually a very good thing, right? If you want to have a testable architecture, you just need dependency injection. If you want to have a decoupled architecture, you need dependency injection. So the Java EE expert groups sat together and looked at the number of dependency injection frameworks out there, and they decided to come up with a new dependency injection. They standardized a new dependency injection model, so they did not create their own, but they just really looked at the things that were working in the other implementations, and they came up with a very powerful new model, which is called CDI, which stands for Contextual Dependency Injection, which is a really powerful model because it does not only do dependency injection, but it also takes care of handling the state which is held in the context. So it injects something out of a session, or it injects something in your request, right? So it's not only dependency injection, but also contextual dependency injection. And another good thing about CDI is that it's made to be extensible. So if it's not in the basic specification, you are free to roll your own extension in a standard way. That's exactly what we're going to do when we show you how to upgrade some of the Spring stuff to Java EE. Because we have a lot of slides, we will cover questions at the end, if you don't mind. Okay. So CDI is a very nice addition to Java EE 6, and we're going to use it a lot in our migration approach. So you say, okay, that's nice, so dependency injection can be done. What about AOP, right? Because I need to have AOP. Well, the first question that I want to ask to you is, do you really want that? I mean, AOP is something that you can shoot yourself in the foot with. I mean, if you end up getting your code all asymmetric and unreadable, right? I mean, because you just add aspects all over the place. I mean, I've seen some horrible implementations using AOP. So actually what you want from AOP is what I would like to call some lightweight AOP. I mean, aspects are not bad, but if you use them too much, I mean, it's like pepper, right? So you need a little bit of it. If you use too much pepper, then that's not going to be good, right? Well, for some people it is, but for most people it's not. So Spring has something which is called Spring AOP, which is what I like to call a lightweight version of AOP. And so does Java EE with interceptors in both the EJB specification and also with CDI interceptors. Right? So we have that. Next thing is, do I need heavy tooling? I mean, probably some of us still have nightmares from, booting up WebSphere application developer, right? So you came in the morning in the office, you started your PC, you started WebSphere application developer, and then your PC just got trampled upon for the next 30 minutes or so, right? So your PC would probably feel like the white car underneath the monster truck there, right? So after it was done booting up, it wanted to take a shower, right? So do you still need those in order to be able to run like a EJB wizard? No, you don't. I mean, about every IDE out there is able to produce artifacts for Java EE because it's a POJO-based model, so you don't need much of the wizard. You just need a couple of annotations in order to get things running, right? So you do not need any heavyweight tooling. You can just pick your favorite IDE, whatever you like, and you can start building Java EE code with that. So just to round this up, we created a little of a capabilities matrix which compares some of the core features of Spring to those same features within Java EE. So it's not an extensive list, but it just gives you an idea of the most important reasons for people to choose for Spring in the past. Well, there's the counterpart in Java EE on the right-hand side of this slide. So I think it's fair to say that we cheated a little bit because there's one point where Java EE 6 does not feature anything out of the box, and this is the case with integration testing. So we added a framework called Arquillian to this slide, and Arquillian is something which is started by JBoss. It's a testing framework for doing integration testing, in-container integration testing. It's really, really nice. If you haven't looked at it, you should definitely take a look at it. It's not limited to the JBoss application server. You can use it on all application servers. And it's a very good way, it's a very good addition to Java EE 6 in order to do integration testing. Right. So just use this metric as a reference. So apparently, everything that you want to do that you did with Spring in the past can now also be done with Java EE. So, okay, well, here's our recipe for migrating your Spring application to Java EE 6. All right? And this probably works. And it's fun, especially if you can present it on a conference, but I mean, it's not very realistic, right? So what we need is some sort of a recipe that will take us there step by step. And well, a couple of slides back, I talked about having a business case in order to do so, and I think that's really important. So you must have a business case in order to do it. So some of your business cases will maybe not take you along our migration path all the way, right? So you might say, okay, well, I can do a few of your steps and, improve my application, and then I just quit, and then it's fine for me. I mean, I don't have the money or the time, or my boss won't allow me to do it. So we came up with a process that can be followed up to like a number of steps. And if you really want to, and if you have the business case, you can follow it all along and do the entire conversion. So we'll show you how to do it step by step. So the victim here is our typical Spring application, which is in this case an old school Spring application. So it's a Spring 1 or a Spring 2 application, which is in production for like a number of years. And typically such applications feature lots of complex XML. Doesn't feature any annotations yet, probably. It has an old or outdated ORM solution, so maybe some JDO stuff or so. Codo or Toplink or JDBC Templates, God forbid. And then maybe you might have a deprecated extension-based web MVC, a web layer on top of it as well. So that will give you some problems to start off with. And then maybe, well, just after adding functionality and functionality to it, well, you have some more technical depth in your architecture maybe. So this application faces some challenges and it needs maintenance now. So we're going to show you how to convert an application like that into a full-blown Java EE 6 application without Spring. So in order to do so, we came up with a migration path of 5 steps, and this is the part where I hand over to Paul, and Paul's going to take you through the migration path.
All right, so let's start migrating. So this is our 5-step, program or step-by-step program to, migrate from Spring to Java EE. And the first step might be a little bit strange to some people, because the first step we're going to look at is upgrade our Spring version. As we said, this is a step-by-step approach. So we're not going to just jump into an application server and start writing Java EE code and just forget about Spring. That's just not realistic. So the first thing we're going to do, we're going to upgrade our technology stack within Spring. And then slowly we start moving towards Java EE. So the first thing I'm going to do is just upgrade my Spring version. And that should be as easy as just upgrade the Spring version in your Maven POM files. Luckily, backwards compatibility in the Spring framework is in general pretty good. So even if you're using an old version like 2.0 or 2.5 or something like that, upgrading to the 3.1 or whatever the latest version is, that should be pretty easy. Note that we're not changing any code yet. We're just upgrading the dependencies, just dropping in new jar dependencies. We're not changing any code yet, and we're not changing any configuration yet. That's a next step. So this should take about 5 minutes. Next, we're going to look at some old frameworks that we're using within Spring. And this is where the real pain lies, because this is actually our technical debt that we have been building up for the past few years. Let's take a look at a typical Spring application. So we have a web layer, and in the web layer we're using Spring Web MVC, but we're using the old style Spring Web MVC, the one that was deprecated a few versions back. So this is still the controller extension-based web framework. And it has been deprecated and completely replaced in the Spring framework by a much better annotation-based programming model, which is better, but not really compatible with the old model. So we should probably get rid of that, because Spring is not going to support it anymore, so, who is? Then at the bottom, we are using some kind of, weird object relational mapping framework like Codo. Who remembers Codo? It used to be, I feel for you. I mean, Codo used to be one of the, cool solutions 6 years ago. But by now everybody just forgot about it. And I don't think it's maintained anymore at all. And at least if you're looking at new developers, they probably don't even know what Codo is. And this is not just about bashing Codo. This is about, all kind of object relational mapping solutions that are just, not necessary anymore, and people just start to forget about them. Since we got JPA, people have been standardizing on JPA, and people like JPA. And well, the other solutions which are not moved or migrated to JPA are just, well, they stop to exist. So we have to get rid of them because in the future nobody will actually help us building Codo code anymore. Besides that, of course, we use some Spring Beans. That's just our dependency injection. That's where most of our business logic probably lies. And maybe use some Spring JDBC templates next to our object relational mapping framework. Maybe some JMS and some other frameworks maybe. So the real problem here is not Spring itself, but the frameworks around it. It's not Spring's fault that Codo is deprecated now and Codo doesn't exist anymore. It is Spring's fault that they deprecated Spring Web MVC, but for good reasons. But I mean, you can't really blame Spring for it, but this is something you have to deal with in your Spring application. So the first thing we're going to do is, and this is going to be a lot of work, this is the majority of work, we're just going to replace, in this case, Codo by JPA. And luckily, Spring has excellent support for JPA. And the programming model is very similar to JPA in a Java EE application. So the first thing we're going to do, we're just going to throw away or migrate slowly away from Codo to JPA. And we could do the same thing for Spring Web MVC. Here I choose JSF, you could use something else depending on what you need exactly. But we're just getting rid of those deprecated frameworks while still using Spring. And well, that's nice for Spring. Spring has support for most of the Java EE specifications anyway. So this will work. You should note, however, this is just an awful lot of work. This is painful. Migrating from one framework to another framework is just painful. It's a lot of work, but well, if you have to go to the future, it's something you have to do. No matter if you want to stay in the Spring world or going to the Java EE world. For now, we're not going to touch any Spring-specific APIs yet. Besides, of course, the APIs that we use to use the other deprecated frameworks. But our application is still running in Spring. It's still a Spring container. We're not even running in a Java EE container yet. This is just all Spring, just an updated version of the Spring application. So this will probably be most of the work. The next step is that we want to start writing some new code. Because, well, probably this migration will take a number of weeks, maybe months even, depending on your team and the work you have to do on it. And while doing this migration, which might take a long time, well, the rest of your team maybe has to just add new features to the application, do some maintenance on it, and it would be a waste if we, well, keep on writing our code in a way that we want to move away from. So we want to start writing the new code in the application in a Java EE model. So we want to start using the Java EE programming model, besides things like JPA, etc. But we also want to start using CDI, for example. Well, there's a challenge. And to understand this challenge, and also to understand the solution, we have to look at how a Spring application actually looks like. If you're going to deploy a Spring application, it pretty much looks like this. You have your servlet container, and the servlet container might be part of a Java EE application server. I've seen numbers of customers that use a full-blown WebSphere instance just to run Spring, and they just use servlets. Well, that's weird, but that's what you see. But basically, you just need servlets, and in a servlet, you just deploy your var file. And this is, well, different from Java EE. If you use Spring, you basically package an application server within your var file. The application server is just part of your application. So what the Spring guys say, well, you don't need this heavy bloated application server, and well, sure. But they just package it in a var file, which is, to me, exactly the same thing, just different place to put it. So we have a transaction manager, we have AOP support, we have dependency injection support, we have JMS support, and etc., 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 all packaged in our application next to the code we actually write ourselves. Well, this is not really a problem, this is not really bad, it gives some flexibility in deployments if you're not if you're not very flexible yourself with dealing with application servers. But this is the model Spring uses. If you look at the Java EE application, it actually looks very similar. The only difference is that our code, that's what we package in the var file, and the rest of the stuff, all the container services like the transaction manager, security support, interceptors or AOP, whatever you want to call it, JPA support, all that kind of good stuff, is already in the application server. Because we're not just using a servlet container, but we're using all those Java APIs built into the application server instead of packaging it in the var file. I prefer this model because my var file gets a lot smaller, deployments start to be faster, and if I have two different var files, well, I don't have to duplicate all those Spring dependencies in both var files to get the class loading right. Well, it's already in the application server, so you have that shared already. So deployments are smaller and faster. What we're going to do now is just a temporary approach. So what we're going to do is say, well, we want to have our Spring code because we're not ready yet to throw away Spring. But I also want to have some Java EE code. That's the new code I'm writing. And I'm going to, well, let them live together. And to do so, we're going to deploy the Spring framework within our application server. This is actually not very strange because what I just said, I've seen numbers of customers who actually use a full-blown WebSphere or WebLogic server instance just running servlets. It still doesn't make sense, but in this case, it's good we can actually use that. So we start using our EGB container and CDI container in the application server, and in our var file we still have the Spring container. This is not an ideal model because we have, well, two different transaction managers, and, well, they don't really know about each other, so they don't play well together. We might have two different AOP solutions. We have the Java interceptors, and we have AspectJ or something in Spring. So this is not ideal, but, well, it's migration. So what does this actually give us? This is still the same application. I didn't actually change anything yet, but I want to add some new code now. And this new code I'm going to write using EGB and CDI and all that, well, new Java EE 6 stuff. But I still want to use and leverage my existing Spring code. So, for example, I write some new JSF code using CDI beans, but I still want to use my existing Spring JDBC templates, because I'm just not ready to throw them away and, well, redo that in JPA, for example. We will discuss it later on, but at this point I just want to reuse my existing Spring code, maybe my data access objects, from my Java EE code. Well, let's get to a more concrete example. Let's say we have this Spring JDBC template. Note this is all modern Spring, just to keep it a little bit more concise, but it doesn't really matter how you would write it. So we have some JDBC template and we go to the database here. Of course I need some configuration here, and the configuration here is the problem, because we can't just say, well, I'm going to deal with this booked JDBC data access object like it would be a Java EE object. No, without this configuration it doesn't really do anything, it doesn't work. So we have to keep using this stuff, including the configuration, including the Spring container. So I'm not going to touch this code. This is my new code. This is a JSF bean, just as an example. And I just want to inject, using CDI, my booked JDBC data access object. And from this new code, I don't care if that data access object is actually a Spring bean or a Java EE 6 component, like an EGB. I don't want to know. I want decoupling here. I don't care about the implementation details of my data access object. This is just plain Java EE 6. But how is that going to work? Because somehow I have to start, well, working together with a Spring container, get a reference of my booked JDBC data access object from the Spring container, and start, well, working with that using dependency injection in Java EE 6. And we're going to use CDI for that. We do need some trickery here, but it's, well, based on the CDI standard, and it's actually just a CDI extension. So we're going to write a CDI extension that get activated when the container starts, and we're actually going to bootstrap the Spring container, like you would normally do when you start your var file in your servlet container. So we bootstrap the Spring container, and then we're going to ask the Spring container, well, give me all the beans that you have, and I will, well, republish them as CDI beans, so that the CDI container actually contains references to Spring beans. That sounds way more difficult than it is. because this is all the code you would need for it. And actually, you don't even have to, you shouldn't actually use this code, because this is just something to make you understand what's happening. But the JBoss guys are working on the theme project, which is now Delta Spike, and they're actually doing this in a much better way. So you can just do this completely by configuration now. But to just make you understand what's happening here, this is CDI Extension. And what we wait for here is, well, we're going to wait until the container starts. And whenever the container starts, I'm going to instantiate my Spring container, like you would normally do, for example, from your web.xml. And I'm going to instantiate it using a configuration file, application context.xml. Then when the Spring container is started, I'm going to look at all the beans it has. In this case, I'm just going to look for one specific bean, but this is just a simple example. And I'm going to republish this bean, which is just a Spring bean. I'm going to republish it in a CDI context, so that the CDI context actually knows about this reference, but whenever I inject it somewhere, it will actually go to the Spring container and ask the Spring container, well, give me that bin, including all your configuration and that good stuff. Okay, so now we have a way to both write Java EE code and Spring code next to each other. But in the end, we wanted to get rid of Spring, because we said, well, we came this way, this far. We got rid of all those deprecated frameworks. We even started writing some new Java EE code. And I don't really have that much Spring code anymore. So why not just get rid of it and start, well, being based on standards only, instead of some proprietary framework. So the next step is, and this can also just cost time, this is not something you have to do in an afternoon. We just replace all the components by Java EE components. Because, well, like Bert showed you already, everything you can do in Spring, you can also do in Java EE. Well, hold on. What about Spring JDBC Templates? There's not really a solution in Java EE for JDBC Templates, which is probably good because JDBC Templates suck. But, well, if you have a lot of code using JDBC Templates, it might be painful or at least time-consuming to migrate to some other solution. I'm going to get back to that. I have two different solutions for that. But let's forget about that for a second. Let's look at some, well, other issues you might run into. What we've been seeing in practice is that the hardest part of the migration here is probably the transactional layer. So migrating away from Spring-based transactional beans to EGB, which is the Java EE equivalent of that. That's where people run into issues, and actually it's pretty easy, so I'm going to show you something. So we're going to migrate away all those transactional Spring beans to, well, basically EGBs. And, well, EGBs are using the transaction manager already installed in the application server, so we don't need configuration for that. And the other nice thing about EGBs is that it has very strong JPA support. Oh, but wait, hold on. EGBs, seriously? Weren't those that evil things that were difficult to configure and took like 2 days to, well, either set up or never get working? Well, no, they're not. A lot of things has changed. If you look at Java EE right now, at Java EE 6, they're just POJOs. POJOs with a few annotations, and those annotations give you a lot of container services. Not so different from a Spring Bean. A Spring Bean is also just a POJO with some annotations on it, or XML, giving you some container services. So let's get to an example again. This is Spring Bean. Once again, it's a Spring Bean, modern Spring, using annotations, but it would be the same, just a lot more code for old style Spring. So this is a transactional Spring Bean. And Spring also has support for JPA, and we already started using JPA, so probably we use an add persistence context, entity manager, and our transactions are started and committed or rolled back automatically. The code looks pretty good. I like this programming model. What I don't like about Spring is that I need a bunch of XML configuration that sets up a transaction manager, sets up my JPA implementation, hooks everything together, and well, people get this wrong. If you don't do this exactly right for your application server with your implementation of a JPA implementation, small things go wrong. Things that are very hard to debug and very hard to, well, get rid of. So I don't really like that. Let's look at an EGB example. That's it. Programming model looks very, very similar. There's even less configuration in code because, well, by default we are already transactional because we are an EGB. So that's easier. Transaction management works the same. Transaction gets started whenever I call the list books method and gets committed if there's no exceptions at the end of the method. I have my JPA integration and, well, it just works. I don't see any XML configuration. You know what? That's because we use an application server. A JPA and transaction manager is already working. I don't have to do anything for that. I don't need to set it up myself and I can't get it wrong. Those are actually a lot easier. Okay, so that's the basic cases, of course. But what about dealing with lazy loading? If you look at the Spring forums, especially a few years back, people were well, complaining there to the Spring guys, well, I'm using Spring and I'm using Hibernate and it breaks. Because as soon as I start rendering my view, I want to do some lazy loading on my entities, and then it breaks. And it tells me something like persistence context closed or session closed or something like that. And well, that's something difficult to deal with. Well, the solution they have on the Spring side is to use an entity manager in view pattern. Or if you use Hibernate specifically, they call it the open session in view pattern. And probably if you're creating a web application in Spring, you're using that. How do you do that in EGBs? Well, in EGBs we have a solution for that too. So let's first look at the problem. In this case we have an EGB, and this EGB is referenced directly from a JSF bean. I'm not saying you should, but just to keep the example simple. So the code example at the bottom is just a JSF example, but it could be well, some other technology. Doesn't really matter. And the problem here is that I have my book, which is an entity, and the book has multiple authors. And by default, multiple authors will be well, dealt with lazily. So if I ask JPA, well, give me a book, it will not automatically join the authors with it, because that will, you know, just get too much data for me. But because as soon as I start rendering here, well, I'm outside of my transaction and I'm outside of my entity manager, it will throw a lazy initialization exception. It will tell me, well, I can't do lazy loading anymore because there's no transaction and there's no entity manager anymore. So I just give up and break. How do we deal with that? We can deal with that completely automatic, like you would do in an open session in view pattern, by making this a stateful session bean instead of stateless session bean. But the state is only bound to the request. So it's very short, well, stateful state. And on the persistence context configuration, we say, well, there's an extended persistence context, which means the transaction is still going to be ended at the end of the getBooks method. So when I call the getBooks method, it will still end my transaction automatically. But when the transaction is ended, I'm not going to throw away my entity manager. That's the default behavior of a stateless session bean. Throws away the entity manager as soon as the transaction is committed. But for an extended persistence context, we just keep the entity manager open. And that's it. We have our open session in view pattern. I'm not saying this is the best solution to deal with lazy loading, but it's at least the easier solution to deal with lazy loading. Of course, if you want to have more performance, you should actually write your own join queries. But, well, it's not always convenient. And we can even solve another problem with this. If you look at Spring, every time a request is rendered, well, we have to, well, at some point close the entity manager, which means all my entities are going to be detached. So let's take the scenario that we have a screen that we show something to the user, some data to the user. The user edits something on the screen and then submit it back to the server and expect it to be saved in the database. For a typical Spring application, we would have to, well, first load the entity, and then when the user saves it again, we have to first merge the entity before we can save it. We have to attach it to an entity manager again. Well, that's just one method call, you could say, so what's the big deal? Well, yeah, it's a one method call, but if you have a complicated graph of relationships, it's kind of tricky. It's really not easy to do merging. You can get a lot of tricky problems with that. So why not just avoid merging altogether? So we could take the stateful approach a little bit further, and we could say, well, this is not a request scoped stateful session bin, but it's a conversation scoped session bin. And we're going to say that by default, we're not going to start and commit transactions. I'm only going to deal with transactions when I tell the containers to do so. So what happens here? I start a conversation here, and a conversation is something that's, well, smaller than a session in a web application, and I can have multiple of them. But they are multi-request. What happens here? I load an account from the database using JPA, and that's the end of the first request. I just show it to the user, show it on the screen. The user is going to do some interaction. But the important thing here is that it's not going to be detached. My persistence context is going to hang around there until the conversation is ended. So I never have to do any merging. And even when I go to the finish, maybe after running through a whole wizard without ever merging, I just say, well, now I want to go back to the database. I start a transaction again by specifying that I want the transaction required. I end the conversation. The persistence context is going to be closed and everything is going to be saved back to the database. But I don't have to do it merging because I was never detached. And in complex scenarios, this is much, much easier. The other nice thing about this, I have less database round trips because I don't have to do transactions all the time to do, well, things that I actually don't want to do. Okay, so we can do with JPA, that's easy. But what about those JDBC templates? Well, the first advice we wanted to give you is, well, just get rid of them. They're just not the right abstraction on top of your database. You tie very hard to your database. You're writing SQL in your Java code. You have to do object relational mapping yourself, which is a lot of work. You have to deal with, well, things like relationships in your object mapping. It's kind of a lot of work. But still, there are some valid cases you might say for doing this kind of stuff if you have very well advanced and specific queries, maybe using specific database features that are not compatible with JPA anyway. Or maybe you just have a whole bunch of code that you have no idea how to migrate. That's possible, because those things tend to get very difficult and hard to understand. So, if you decided not to throw away those JDBC templates and stay there, maybe we could use them from Java EE, and actually we can. So what we're going to do is use the JDBC templates, which is just a Spring API, and we're going to use them within Java EE. This does, of course, mean that we are pulling some Spring dependencies in the Java EE application, but that's just the APIs. We are not going to boot up a Spring container, because JDBC templates just don't need a Spring container. The nice thing about JDBC templates is that, well, you actually just need a data source to construct a JDBC template, and you don't need a Spring container for anything else. So let's do that using some CDI magic. The top right code example is a CDI producer. What we're doing here is we're injecting a data source using the JDI name. This is very similar like how you would inject data source in Spring. The data source itself is not a Spring class. It's just, well, the JDBC. Well, is it JDBC? I'm not sure. I think it's in JDBC. Then we have the producers annotation. And whenever we inject something from CDI, CDI will actually go look at producers methods and say, well, is there a producer method that can produce some kind of instance of this type? And there we're just going to create a new instance of simple JDBC template using the injected data source. And that's all we need to create a simple JDBC template, and it's actually very similar to what you would do in a Spring application. The bottom code example is just some Java EE code. It's just some, maybe an EGB or there's some CDI bean. We just inject a simple JDBC template which is of course a Spring API, and we start using it like you would from Spring. And this way we can, well, use this stuff within our Spring Java application. Nice. So we have our JDBC templates. Well, then in the end, we don't have any Spring code anymore, which is good. And then we can get rid of Spring altogether. We don't need to start up the Spring container anymore, so we can get rid of all the configuration files. And we also don't need all those, well, jar files anymore. And this is nice because if you look at a typical Spring application, they have like 40, 50, 60 dependencies defined in Maven on all kind of frameworks and all kind of Spring APIs. And if you look at a typical deployment, a typical var file, for example, they're easily like 50 megabytes or even larger, because you have to package all your frameworks in your var file. And we're just going to replace them by one. We're just going to replace them by, well, the APIs from Java EE. And as you can see, the scope is provided. We have to use them during build time, during compilation. We are just using APIs, not implementations. And they are already an application server. So we get very small var files. Then there's one more thing. And this, you should probably not do this at the end, but it just makes more sense for this talk. What about testing? Java EE pretty much used to suck at testing, because how are you going to test an EGB, for example? And Spring, on the other hand, was pretty good at that. We can do some, well, say in container tests in Spring. And to give an example, how would you test this code? This is an EGB, it's doing some transactions, it's doing some JPA. Of course you could write a unit test for this. And for a real unit test you could say, well, I'm going to mock out my entity manager. Yeah, great. And what are we testing exactly? That we can call the mock object correctly? That doesn't make any sense. The only thing interesting in this code is the query itself, because that's the thing that I'm going to mess up, and that's the thing I want to test. The only way to test that is using a real database, using a real application server, so I can also test my transaction management and stuff like that. So we do need to deploy something to a real application server. And for that, we're going to use Achillean. Achillean is a tool created by JBoss. It's not part of the Java EE specification, but it doesn't have to be, because it's just a tool. And what we're doing in Achillean is create micro deployments. So instead of packaging up our whole application in a var file and deploy that and then run some tests, like, well, probably the thing you would do in the past, we are just going to deploy a few classes with a few configuration files, deploy that, which just takes a second, or, well, probably less actually. And then we're going to run our test in the application server, like it's just part of our production code. Let's take an example. This is Achillean. Well, this is a test in Achillean. So basically this is just JUnit. The only difference is we annotated with at Achillean at the top, so that Achillean can actually control the life cycle. The next thing we have to do in Achillean is define a deployment method. And a deployment method, well, actually defines what I'm going to deploy for this test to the application server. And there's just a few classes. In this case, it's just my single entity and my single data access object. But I also want to use CDI and I also want to use persistence JPA, so I'm going to deploy a beans.xml and persistence.xml, and that's my deployment. It's almost nothing. What's going to happen if I start a test using Achillean is actually going to package this up in, well, depending on what application server you're using, but it might be a real var or jar file. It's going to deploy that automatically. And because the deployment is so small, it just takes, well, microseconds to deploy. And our test case itself, so this class, will also be part of the deployment. So our test is going to be deployed in the application server. And because of that, we can start using CDI to use @inject to actually, well, get reference to our data access object, which might be an EGB. And because it's an EGB and it's running in the real application server, we have our transaction management and our data source with our real database, and everything just works like in production. But we can, of course, just write our asserts, just basic unit testing, but this runs in the container. Well, that's exactly the model we need, and this makes it very, very easy to do integration testing. So if you use Java, well, take a look at Auxilian. By the way, there's even a plugin or integration for Spring at the moment. So even if you're using Spring, you should still take a look at Auxilian probably. Okay, back to you, Beth.
Okay, so we have a couple of minutes left to do wrap up. So the important question to ask is, now that you've seen the way to migrate your Spring application to Java EE 6, is if it's all worth it, right? So, actually, all right, so you know where this is going. So, like I said in the beginning of the presentation, of course, we can do this for fun and having like a very religious discussion about which framework is better. But I think there are some real business cases out there where this can be applied. And in fact, we've done it a number of times. So the question, if you want to do it, is, well, it all depends on your situation. So do you have enough pain in your current application that you are facing a serious upgrade? And if you have to put in a lot of work anyway, why not take the extra steps and bring it to the standard, right? So in my case, I say, well, do you want to stay in blissful ignorance, or do you want to face the painful truth of reality, right? So it's about taking the blue or the red pill. It's always the case in life. So the other interesting thing is, if you've migrated away from Spring and you've migrated all your applications away from Spring, so is there still a life after Spring? Or so should it just die? Or is it still interesting that we have the Spring guys around? So I think it's really important that everybody understands the difference between innovation and standardization, right? And Java EE clearly is the product of standardization. So it's like a process of vendors sitting together, looking at different implementations, and then coming up with a standard implementation to solve today's problems, right? And so for a whole number of things that you need to be able to solve today's problems, the standard is excellent. But then, of course, there's also some customer assignments where we need to have, actually, we need tomorrow's technology in order to be able to solve those problems. So there should be another process where we innovate, right? And innovation is really important because it's trying to make implementations for ideas of how to solve, well, the problems of tomorrow, essentially, or maybe the problems of today. So open source has played an enormously important role in that over the past 10, 15 years or so. So, I mean, that shouldn't go away. I believe it was a quote by Adam Bean who said, premature standardization is the root of all evil, right? So if you take a look at entity beans, for example, you know exactly what I mean, right? If you put things in the standard too early and you haven't really thought about the impact of your standards, then, well, things will get really messed up and it will take, well, 10, 15 years before they can be pruned out of the standard, right? So do not mix up innovation with standardization. So we need the Spring guys around. We need their, actually, I think we need their R&D dollars, just like we need JBoss's and Red Hat's or IBM's and Oracle's R&D dollars in order to do innovation. And then, as soon as ID is starting to be picked up and starting to fly, they should go to the JCP, form an expert group, and try to standardize upon those different implementations. Take the best from implementation A, take the best from implementation B, and then put it into the Java EE platform, in a future version of the Java EE platform. So it's really important that we should not mix up innovation and standardization. The Spring guys have played an important role, and I think they should be doing so in the near future, but I encourage them to go to the JCP some more, right? So, in an hour you can just cover well, not everything that we want to talk about migration, so there is more. If you're interested in migrating, Paul and I have been writing up a very extensive and elaborate article series. It's a 4-part article series in which we completely migrate an existing application from Spring to Java EE. So we took the Spring Pet Clinic application, the demo application from Spring, and we completely migrated it from Spring to Java EE 6 just to show you how it's done. So if you're interested in looking at that, the article series is published by JBoss on a website called howtojboss.com. So go to that site, just search for a Spring to Java EE migration, and you find the article series. So there's a lot of background reading in there as well. And it comes along with a link to a GitHub repository where you can find all the code and all the steps for performing the migration. So you can see some actual examples of how it's being done. So if you have any questions, then please feel free to reach out to us. So we are both pretty active on Twitter, and I will also show you our email addresses in a bit. So please send us your questions. And I think we have like a couple of minutes left, maybe 4 or 5 minutes left, so we can open up for questions. Does anybody have a question? Okay. So the question is, can you also use CDI in Java SE? Yes, so the reference implementation of CDI is Weld, and Weld can be bootstrapped in a Java SE environment, so you can also use CDI in Java SE, yes. No.
So to add to that, in Java EE 7 it will be standardized to run in SE. So CDI will be running in SE standardized in Java EE 7, and you can already do it now. Yeah. Sure. Sorry, well, can you repeat that? So the question is there an alternative for add configuration in Spring? Not in the standard, but there is in some CDI extensions. So if you look at, I think it's now in Delta Spike, Apache Delta Spike, you can, well, use it based on CDI. Yeah? Yeah, this is right. And it really depends on what you did, well, in Spring. So it's hard to say, well, it's easy and just do it. It really strongly depends. And some applications it might be very difficult. You might, well, be better off looking at an alternative for JSF. Something that I'm doing myself a lot at the moment is just using JAX-RS web services together with HTML5 JavaScript user interface. So. Yep. So the question is, how do you set up test data if you use Archillion? So there are different answers to that. One of the most easy ways is to use an EGP. That's a startup singleton bean that gets, well, started automatically when you deploy something. I use that myself a lot for this kind of purpose. There's also integration in Archillion for DB unit, so you could be using that. Yep.
How would you begin the process of migrating over if you don't have access to either a full Java EE container or at least a pretty standard?
Well, if you're not going to get it anytime soon, I'm not so sure you should be migrating, because that will always be like a lot of trouble if you're not going to be on the full EE stack. It is possible. You can bootstrap most of the frameworks like CDI using Weld or JPA, etc. In a server container, but it's never going to be ideal. And if you're, well, facing this problem and you're going to be sure that that is going to be a problem for a long time, I wouldn't be so sure you should migrate.
Yeah, just to add to that, I think the true power of Java EE is only unleashed if you use all of the APIs together. I mean, if you can use JSF, CDI, EGB together, that's where the true power of Java EE lies. So if you can just have like a partial implementation of that, I think then you should consider not to migrate.
I'm looking at this right now. We're looking at actually moving away from full stack. EE containers and Transactional.
Okay. So the other thing is, well, Java EE 6 is a standard which was published in, 2009. So if you're still on EE 5, I mean, it's the same thing. Well, Sun always shouted from the stage, well, are people still on Java 1.4, right? So, but I think it's about time that we address the fact that, you know, being on J2E 1.4 or Java EE 5, then you're really, really outdated for building enterprise applications that you bet your business on. So it's about time to upgrade. And I mean, those application servers have been around for 3 years now. Actually, none of them are still in a .0 version, so most of them also have had upgrade releases. So I think it's about time to migrate to a full stack Java EE server if you want to go there. Right. Well, I think it depends on the case actually, but I know from my own experience that it can be a tough discussion. Yeah. Yeah.
Is there a minimum JDK version
I think the recommended version is to run it on JDK 6, but it also runs with JDK 7.
Based on your experience, you guys using a lot of this stuff. When did you guys, was it epiphany? When did you decide, hey, Spring is passe? When did that mentally come to you guys? Because the 6, as you mentioned, 09, and a lot of applications for this still don't have it available. I mean, I'm a JBoss guy. I'm sure I can open source, but we actually have the enterprise edition of JBoss. And they want support, so they're not going to go for it. So I'm just curious, like, when did you guys wake up one day and the company say, hey, you know what? I don't know. Spring is, a framework. I want to go with those.
Do you want an honest answer to that?
Yeah.
Okay. So the honest answer is that I didn't like Spring from the beginning because of all the XML configuration. So I really just hate XML. That's just one reason. And then the other reason is that I saw the use case of Spring for a lot of customers, and then the architect in charge of the project just used Spring as an excuse to drag about every framework in the application that was out there. So I've seen a lot of very bad implementations, not because of Spring, but just, well, they use Spring as like an excuse to open up the application server and get about every framework in that was out there. And that led to horrible dependency management problems and stuff like that, right? So those were two reasons for me not to really like Spring. So I wasn't really promoting writing Spring applications. And then the other thing is, and I mean, that's something for me as well, I've seen a lot of presentations from Spring guys where they were just bashing the hell out of Java EE and J2EE. And I think it's good if you want to have change, but if you do not work with the expert groups in order to bring change, I mean, then, well, somebody has to say, well, maybe wake up people, there's also the other way around. And so, well, we woke up someday and we decided we're going to do a presentation like this just to, get the message out there that it's not only just a way of bashing Java EE, but there's also the other way around. Now that Java EE finally is on par with most of the Spring stuff. So that's the honest answer.
Because it's a lot more involved, has a longer life cycle, like you said. So it's not that always going to be plug in. Whatever 6 is doing now, some of the other frameworks are going to get ahead of the game.
Sure.
We're always going to be fighting.
Yeah, but I don't think it's a fight. I think it's important that we have like a standard which you can really build some of the, like 89% of your application with, and then you need innovation in order to be able to address tomorrow's problems. But I would wish that all of the innovation that is going on is eventually being brought back to the specification. Right.
So the lady in the back is jumping up and down too.
Okay.
So probably take the next one offline.
Okay, thank you.